to look a little bit today at how we can use models sometimes to solve fraction problems. So looking at our first problem, of the 30 students in a class, 2/3 are boys. How many boys are in the class? Well, let's think about what we're looking for here. How many boys are in the class? What does it tell us? It says 2/3 are boys. Well, what is that 2/3 of? That's 2/3 of the class of the 30 students. So we want to find 2/3 of 30. And if we think about that, what we're really wanting to do is we want to take the whole group of 30 and split it into 3 parts. And the reason we're doing 3 parts is because we're wanting thirds. And if you split 30 into 3 parts, 30 divided by 3 is 10. Each part has to be 10. So in this model, the 10 represents 10 students. So we've taken the 30 students and split it into thirds, each third being 10 students. Of those students, 2/3 or 2 sections are boys, and 1 section then would be girls. So if we look at what we need to answer our question, it says how many boys are in the class. Here are the boys, so there are going to be 20 boys in the class. Now, I'd like to point out to you that this is actually a multiplication problem. Anytime we have a fraction of something, that's going to be a multiplication. So we're really doing 2/3 times 30, and that gives us 20 boys. Another model we could do something as simple as this, where we have every 2/3 means 2 out of every 3. So actually, it's going to be easier even than to do circles than to do letters. So boy, boy, girl. So out of every 3 students, 2 are boys. So if we kept going until we had 30 students, this model takes a little bit longer, but if you didn't understand the other model, this one might make more sense to you. So far we have 3, 6, 9, 12, 15, 18, 21, so we need 9 more students. And once we get that done, if we look, 3, 6, 9, 12, 15, 18, 21, 24, 27, 30 students. If we look at that, 30 of those students are boys. Notice, by the way, that that's 2 out of 3 of the columns. So that's another, there are 20 students, rather, who are boys. That's another way that we could show this particular problem. Let's look at another similar problem. 4/5 of a group of students who were surveyed said they like school pizza. If 40 students were surveyed, how many don't like school pizza? Take a moment, pause, and see if you can do this one, and then go ahead and proceed and see if you have gotten it correct. All right, so looking at this one, we want to find how many students don't like school pizza. What we know is 4/5 said they do like school pizza. And there were 40 students surveyed. So we're looking, once we can do this one of 2 ways. We can find 4/5 of 40, and that's going to be the students who like pizza, and we can then subtract that from 40. Or we can find that if 4/5 do like it, then 1/5 of 40 of the students don't like it. This model is the one I like the best because it's the quickest, so I'm just going to show you that one for this problem. When we look at 40, we need to split it into 5 parts and then keep 4 of them. So 1, 2, 3, 4, and 5. 40 split into 5 parts is 8. So my rectangle represents the whole class, or whole group rather, of 40 students who were surveyed, and then I split it into 5 parts so that I can then show that 4 of them like school pizza, and that means 4 sections like school pizza, and then 1 out of the 5 sections of kids don't like school pizza. So when I look at this one, my answer is here. There are 8 students who don't like school pizza. Now, I could have done that one the same way I did the last one, but it starts to get a little bit cumbersome to write out that many letters. So if you understand this model, use this model. If not, then you could do the other way where you actually draw out all 40 people. Now, this next problem is a little bit different. A university is researching the effects of a certain fertilizer on crop output for corn. In other words, they want to know, is the fertilizer going to help grow more and better corn? To test this, they've planted 1/3 of an acre of corn. They have fertilized 1/4 of the corn with fertilizer. How much land does the fertilized corn cover? Well, the first thing we need to do is we need to plant some corn. So we're going to plant corn in 1/3 of an acre. And then we're going to fertilize some of the corn. Now what we're fertilizing is 1/4 of the 1/3 of an acre. So that's what we're going to want to find with our picture. So we've drawn the 1/3 of an acre. Now we need to shade just 1/4 of that. So if I split it into 4 parts, I'm going to shade one of those, and that one part is the section that represents the fertilized corn. Now notice in my drawing I do need to continue my lines across, not because I'm planting corn in those empty spots or fertilizing it or anything, but because I need all my pieces to be the same size. So when I look at this, I should see that there's 1 out of 12 pieces, or 1/12 of an acre, that has fertilized corn on it. Notice on this problem, this model looks different than the last two. On the last two, we were finding a fraction of a whole number. On this one, we are finding a fraction of a fraction. We still could solve this one with multiplication. What we really did here was 1/4 times 1/3. So we could still solve this using multiplication. Another example of that, and one that probably hits home with anybody who's ever really eaten pizza, your family orders a half cheese, half pepperoni pizza. You only like the cheese and eat 1/3 of that section. What fraction of the whole pizza did you eat? So first let's draw our pizza. Here's our pizza. And let's split it in half. Well, we split our pizza in half, and this half, let's say that this half is our pepperoni side. And the other side is our cheese side. So this side is cheese. We're only going to want to eat the cheese section of the pizza, so I need to eat just from that half, and I'm going to split it into 3 equal sections because I'm only going to eat 1/3 of the part that has cheese on it. And then I need to continue my lines so that all the pieces are the same size. And when I do that, I'm going to see that I ate 1/3 of half of the pizza, which means I really ate 1/6 of the whole pizza. So 1/6 of the pizza is what I ate. Again, this could have been a multiplication. 1/3 times 1/2. Anytime you see a fraction of another number, you can always do that as a multiplication. And let's look at one last example. This is another type of problem. Bags of pasta weigh 2/3 of a pound each. If you buy 5 bags, what will the total weight be? So this is different from all of the others because I'm taking one number and I am multiplying it by 5, or I'm doing it over and over. In this case, I want to do 2/3 5 times. So I can show that by, here would be 1 whole, but each bag of pasta only weighs 2/3 of a pound. So my whole here represents 1 pound. Each bag of pasta only weighs 2/3 of a pound. So that's how much one bag weighs is what I'm showing you. That's what's shaded out of the whole pound. Now, if I want to get another bag of pasta, I'm going to need another section here that I'm going to split into thirds. So I'm going to shade 2/3 of that. Notice I've now used 1 1/3 pounds, or I now have 1 1/3 pounds of pasta. And I have enough space here still for another bag of pasta because each bag is 2/3 of a pound. So I've now got 3 bags of pasta, which is a total of 2 pounds. But I'm not done yet. I'm at the end of my 2 pounds, but I'm going to draw another pound on here to be able to accommodate more pasta. Splitting this into thirds, I now need another bag. So I've got 4 bags at this point because I've got bag number 1, and then I have bag number 2, and then I have bag number 3, is here in the blue. And then I have my fourth bag of pasta here. And I need one more bag. And here's a third of a pound for that bag. That's going to fill up that whole pound. And then from the next pound, I need another third. So if we look now, here's bag number 5. Now I did those lines that I made a little bit taller to show where each pound ended or began or ended. That way it's easier to go back and read. So if I look at this, my total weight is 3 1/3 pounds. So this part is 3 pounds, and then here's the other 1/3 pound. So the total weight, 2/3 pounds, 5 times, is 3 1/3 pounds. Understanding how to model fractions can really help you when you're solving word problems, especially when you're not sure which operation you're dealing with. If you can draw a picture to figure out, that's just as well as understanding what the operation is.